Okay, so today we're doing compound interest investments with regular additional payments to the principal. So what that means is you are investing some money and you are also going to make extra payments into it. So you might have decided I'm going to, you might have inherited a fair bit of money. I'm going to put it in a bank and I'm also going to add extra to it. So then in years to come, I've got a good little lump sum. So you will see here, if you're doing a recursion model, that it looks like this. And so where this R is, it's not been shown. I'm going to do it here. Do you have that written in? No. So this R, it's missing it, will be 1 plus the rate over PPY over 100. Okay, so the recurrence relation will be the same, and just take note, if you're adding additional payments, it's actually plus D. So, so D is the extra payments put onto that. So in Finance Solver, what you are going to see will be that when you do in Finance Solver, payment will be also negative because you're giving it to the bank. PV will be negative as well because you're investing. So just take note of that. The FV in Finance Solver will be how much money you've accumulated and what the bank have to give back to you. So if I do this example, Noor plans to travel overseas when she finishes her VCE. She already has 1,200 saved and thinks she can add an additional 50 each month. So she plans her savings account. The account pays interest rate of 4.8% per annum, compounding monthly. So we've been given a few things here. This 1,200 is going to be my negative PV. Okay, the 50 each will be my negative payment if I put it into Finance Solver. Compounding monthly means PPY is 12. This is my interest rate, and so on. Model this investment using recurrence relation. So they actually want me to set it up like that. So I'm going to do it over here. I'm going to work out the R first. All right, so R, which I just wrote over there in green, is 1 plus the rate over PPY over 100. So in this case, it'll be 1 plus 4.8 over 12 over 100. So we'll work that out. So that will equal 1.004. So if I go to write the recurrence relation, I need to have a VO, which is 1,200, and then I have to write the VN plus 1 rule, which is the R, which is 1.004, times VN, and then we're going to plus the payment, which was 50. So there's a recurrence relation done. It then says and then we're just showing you how you can do it, obviously, on the calculator using the recurrence pattern. I think I might have... Sorry? Is there too many zeros in the VN plus 1? Sorry, there's too many here, yeah? Okay, so we have amortization tables for these things as well. So remember compound interest with additional payments, that's going to be a little bit different because you're going to be adding more. So you'll see this is what she began with. So then we found the 0.004 amount of interest, so whatever that was, so 4.8, it was 0.4%. So the interest rate was 0.4% per month. So if you look at that, if you do 4.4% of this 1,200, you get $3. So even though she's adding $50 every month as well, she gets $3 interest. So what she's actually, her amount, the principal increase, is actually going to be 53. So even though she's out of her wallet, she's only paying $50. The account's going up by 53 because she makes interest. So then if you look at the next one, if I said 0.4% of that amount will be this. So you can see there's how you work the interest out. So it's still doing, when you calculate interest, okay, this 0.4, this is because it was from the scenario before. And remember, she had 4.8% and it was monthly. So if I divide it by 12, it's 0.4% per month. Yeah? So that's what I'm saying. So if we were going to find the interest rate is same, the way you calculate it is still the same way as we did with the loans. So what you could say, if you want to, we said interest equaled the percentage rate per period times by the balance before, or the previous, we were calling it balance before. So if I did 0.4% times 1,200, you essentially have that, and it ends up equaling the $3. That's what you'll find here. All right, so we just got to be careful with the principal increase payment is actually going to say this number here is actually, you've got to add the payment plus the interest you earned. Okay, so that is the principal increase, how we're finding that. And obviously if you're trying to find the balance of an investment, it's going to be the amount before plus your principal increase. So there's like that. All right, let's go do this little example over here to help us. So Lars invests $500,000 at 5% per annum compounding monthly. He makes regular deposits of $500 per month. What is his investment? So what is the investment after 5 years? So in that, I just got given a lot of things. He invested $500,000, so that's negative. 5.5% is the I. Compounding monthly is telling me PPY equals 12. 500 per month, this is he's adding, so it'll be a negative PMT. And it said for 5 years, so it's 5 times 12 because it's monthly, and they're saying what's the value, so FV is the question. So you can see I've typed them all in to my calculator here. This was the only thing I didn't know, and I pressed enter. So after 5 years of him, after he's invested $500,000 and adding $500 a month, he now has $692,000. 292 and 30 cents. Okay, so there's the answer. All right, so the only difference with this one, investing, you are now adding more into it. So you're constantly adding into it. It's a sort of an example of a superannuation. You add your super in every payday, and it's already making money with the interest rate that it's getting, and you're adding. Here's a couple of more examples. So a loan of, so I think these are mixed examples now, so we need to be careful. So a loan of $5,000 at a rate of 4.5%, adjusted fortnightly, is to be repaid in fortnightly installments of $42.98 over a period of 5 years. The formula needed to determine the amount owing after 3 years is, so this is a loan, this is a reducing balance loan. Okay, so first I'm going to go right, this is a reducing balance loan. Right, so we know it's a reducing balance loan because it's taking off. So we're just going to show, it says show the formula. We're just going to use show what we'd put on Finance Solver. So N, it wants to know the amount still owing after 3 years. Now we've got to write a few things out. What is fortnightly? PPY is 26. Good. So if it's 3 years, it's 3 times 26. The interest rate per annum was 4.5. The PV was positive 5,000 because it's a loan. But the payments, because it's a reducing balance loan, is negative. And the FE is what we want to still know. And PPY, we need to make sure that changes to 26. So that's fine if you show that for this type of thing. They have not said use like show recursively, just show the formula. That would be fine. All right, so we'll go. Okay, so I end up with negative 2136.07. So that means how much do you still owe? Still owe. So negative means you have to give the bank. So 2,136.07. Good. All right, let's do the next one. Alan has 15,000 to invest in annuities investment. So annuity is it's his money, but so investment. He contributes a further 600. So this is actually like compound interest with additional payments. So and he earns at 6 months, every 6 months, a further 6 every 6 months. He earns an interest at 5% per annum, and the interest being credited half yearly. So see how they both matched up? He's making a payment every 6 months, and they said interest was done half yearly, which is the same. So Alan plans to withdraw the total amount in 10 years. So which of the following will calculate the following? So I think I've accidentally deleted the multiple choice. So we're just going to pop it into our finance what we would do. So N is going to be 10 years. So calculate how much money he would have, and it's half yearly, so it's 2. So this told me that PPY was 2. This was an investment. I've got the interest rate there. So PV is negative 15,000. The payments, he's making another negative 600 every 6 months. FB is my question, and PPY is 2, and CPY equals 2. So let's find out. Did that answer, and I get a positive, which is good, 39906.04. So he, after 10 years, he's got $39,906.04. With this one, this is an exam question. It's question 24, suggesting to me it's a little bit difficult, and also suggesting to me because 29% got it correct. Have we done this one? No? All right. Marissa plans to retire from her work 10 years from now. Her retirement goal is to have a balance of $600,000 in an annuity investment at this time. The present value of the annuity investment is this, on which she earns a rate of 3.4% per annum compounding monthly. Okay, to make the investment grow faster, Mariska will add a $1,000 payment at the end of each month. 2 years from now, she expects the interest rate. So this is a change in scenario. So 2 years from now, she'll expect the interest rate to fall to 3.2% per annum, but it will still be compounding monthly, and it is expected to remain at this rate until she retires. When the interest rate drops, she must increase her monthly payments if she is to reach the retirement goal. The value of this new monthly payment is what? So what you need to know is, first, we want to know what her first monthly payments were. So Or did it say that? It did say that, didn't it? She made 1,000. So let's go and look. We want to know how far, on the first scenario, she gets to 2 years, doesn't she? So we're going to do 2 years first. So we'll see what's happening at 2 years before it changes. So it was monthly, and it was... Oh, no, actually, they've already told us, didn't they? The present value of the... Oh, no, we don't know. Okay, so it's monthly. We want to know what happens in 2 years. The interest rate at the beginning was 3.24, so I'll put that in there. PV, what I know she's investing at the start is what they said her present value. So that's going to be, and it's going to be negative, isn't it? Because she's investing into the bank. Okay, and it said her payments, she was going to make $1,000 payments every month. And FV is what I want to know. I want to know how much she has at that 2 years, and PPY is 12. So let's do that and work out what this value is. Okay, so at 2 years, we got this amount. This is how much she has in her investment. Things are going to change now. So that's where I'm going to put in this. This is actually I'm going to pretend we're starting again, and this is going to be my new PV. Okay, so if we've got they said, what does she have to change her payments to? So if we're thinking we've gone 2 years already, but she wanted to retire in 10 years, so how many more years has she got? 8. So we're going to say 8 by 12. There, she's now got this new interest rate, which is, what was it, 3.2, because it dropped. The PV is, I'm going to put this new amount in. So I'm going to still say it's negative because it's like an investment. So this is her new PV. Payment is what they're asking me. They're saying, what should she increase her payment to? See, there it is. Now, FV, we know what we want it to be. We want her to come back and have 600,000, yeah? Because that's what they said. She wanted to retire on 600,000. So I put positive because it was coming back to her. And PPY equals 12. So this is good because I've only got one thing missing, and it will be what she has to increase those payments to. So let's go do that. And we get negative, which is good. She's got to give the bank extra payment of 1854.05. Yep, and is that one of our answers? Yep, it looks good. And there you go. This is a summary of your finance solver. I'm not too worried if you look at that or not because it's on your summary sheets. These guys here, I will show you there. See, there's finance solver. A little about that otherwise. So notes on what to do with each one of them. So probably just use this sheet and not stress too much.